Teacher, I don't really get how to answer question 1A. Can you teach me?
Of course. So basically, we look at the question first. So the question is find the coordinate of the points, which is the tangent line to the curve, which is the intersection between the tangent line and the curve is parallel. Where the tangent line actually is parallel to the x-axis. So what does this mean? This means about the dy dx equals to 0 because it is basically with the graph. It will be a straight line. So when the straight line, the dy dx will equal to 0. That's it. So this question I think is pretty simple. So first we look at the x equation. So x equals to 9t squared minus 1 3t. So complicated. Can we like simplify it? Since the below the fraction is only 1, so which is 3t, and then we can separate it by using this. And then we simplify again, which is 3t minus 1 over 3, and then this t, since they are on the below it, and this is the power 1, so when we bring up, it will become t power minus 1. And this equation we want to differentiate it, which is from dx dt equals to, here is the number t power 1, so the 1 bring it out, and the t 1 minus 1, the power minus. So here the power bring in front of it 1 over 3 t minus 1, and here the power minus 1, and we got this, it will become 3 and plus, see, negative, positive. So 1 over 3 t minus 2 t power negative 2. So when you put it back into normal thing, because this thing is so bad, 3t squared below it. That's for the differentiation for the equation x only. So now we want to find the equation for the y. So write it down first. So let's look at it. Let's simplify it. So as the same step for the x, separate it and simplify it. dt plus 3 plus 1 over 2 t minus 1. Same step. So we differentiate for the y equation. The same thing. Since here is 1, so times 1 t and then the power minus 1. Since here they are the integer, they got nothing t, so this one will be disappear, plus 0. Here, the power in front, the negative 1 minus 1. So here we will get 3 also, since here t power to 0 equals to 1. And here plus minus become minus 1 over 3 t power negative 2. So we bring it down back. That's it. That is the dy dt. So since what I told you is the dy dx equals to 0, but I only got this. How do I make it become dy dx? So since dy dx and is known as dy dt times with dt dx. So dt and dt can be cut or can be reduced and become the dy dx. And since the dy dx is 0, so let me put it first. So the dy dt, what is dy dt? Dy dt is this one, 3 minus 1 over 3 t power 2. So 3 minus 1 over 3 t power 2. So the dy dt, we put it up there, and the dx dt, we put it down. So which is 3 plus 1 over 3 t2. Since we want to like make the t, right? So here we move it to the left hand side, it will become 0, because 0 times 1 will become 0. So what left is this. So how do we solve this? It will seem like so complicated. So we move it, we move this one, we move the negative 1 over 3 t squared, we move it to the front, it becomes positive. It's more easier than we solve it in the positive, so with times with 3t squared. So here it will become 1, and 3 here it will become 9t squared. Since here what we need is t, so 1 over 9 times with 9 times with 1 over 9 will become t squared. So for the t, it will become plus minus square root 1 over 9, and it will become plus minus 1 over 3. That's how we got the t. So since we got the t, so we need to sub it to the x and the y so we can get the coordinates. So when t is equal to negative 1 over 3, since they are plus minus, so the x, just put it inside, sub inside, square minus 1, 3, negative 1 over 3. So when you sub it, you will get 9, 1 over 9, then minus 1, negative 1. Since here the upper part of the fraction will become 0 and negative 1, so we will close to 0. And for the y, just the same thing, but just to substitute, just sub into it. So for this one, you will get negative 1 and negative 1. So it will become 1. So that is our what our coordinate, which is 0 and 1. And since we got 2t, so we need to do another one, which is t equals to 1 over 3. They are the same, but please look at the plus minus sign. They are different actually. So square minus 1 over 3. So the up one also will become 0, and the down one is 1. So 0 over 1, which is 0. So for the y part, just like usual, substitute it, but without the negative sign, since the t is 1 over 3 positive. So it will become 5 over 1, which is 5. So for our coordinate, it will become 0 and 5. So these two coordinates is if you answer the question, which is find the coordinates.
Yoga,
Yeah.
can you teach me how to do this question? Tangent line curve is parallel to y-axis.
Oh yeah, sure, I can teach you that. Okay, so for question B, is there any tangent line to the curve which is parallel to y-axis? Justify your answer. As how you mentioned earlier, to the x-axis, right? Because we know dy dx equals to 0. But how about parallel to y-axis? Is there any tangent line? As you can see, dx over dt can never be 0 because 3, earlier what you thought is 3 plus 3 squared, this value is always greater than 0, which means the square, which is whatever value, is it positive or negative value, will always, when square root, the value will always be greater than 0. It can never be below 0. So here we can conclude that there is no tangent line parallel to y-axis.
Bella, do you know how to do this question number 2? 2a.
Yes, I did. I already did it. You want me to teach you?
Yes.
Okay, let's start. So for question 2, the equation of a curve is x squared minus y squared plus 2x plus 4y equals to 0. So the question asks, determine the standard form of the equation and identify the conic. So for step 1, you just need to rewrite the equation that the question gave. So for step 1 is you group the terms, you group the x terms and y terms together. So from the equation, you will get x squared plus 2x minus in bracket y squared minus 4y in bracket equals to 0. So for step 2, you need to complete the square. So if you don't want to be confused, you just complete the square one by one. So for the x terms, x squared plus 2x, when you complete the square, you will get in bracket x plus 1 squared minus 1. So minus, you just need to write it back. So for the complete square for y squared minus 4y, you will get in bracket y minus 2 squared minus 4 equals to 0. So step 3, you just need to write it back, and then step 4, you need to simplify it, which you minus 4 minus 1 here, then you will get 3. So until you reach this step, you need to identify the conic equation form, which is in bracket x minus h squared minus y minus k squared in bracket equals to c. So when we get here, then you need to divide this 3. You need to divide this 3 by 3, so you get 1 here. Then you get your answer for the standard form of the equation is y minus 2 squared over 3 minus x plus 1 squared over 3 equals to 1. Thus, the conic type is hyperbola. Hello, I already did question 2a, but I don't know how to do this big question.
Oh, question B. Okay, let me show you. Okay, this is the question B, which is state the coordinates of the center, foci, and vertices of the conic. And we will give you answer in third form. So first thing first, we need to know the standard form of vertical hyperbola, which is given by y minus k square over s square minus x minus h square over b square equal to 1. The equation of hyperbola given by y minus 2 square over 3 minus x plus 1 square over 3 equal to 1. So this is the formula of the center, foci, and vertices, which is, for the center is h, k, foci, h, k plus minus c. We can find the c by c square equal to s square plus b square. For the vertices is h, k plus minus n. We move to the step 2, which is we will find the center, foci, and vertices. For center is, we know that h equals to negative 1, k equals to 2, and the formula given by hk, and this is the center what we get, negative 1, 2. For foci, we get c for third 6, and the formula here is given, and we can write it down like this, negative 1, 2 plus minus third 6. And the vertices is, like we can see here, the formula given, and we can write down negative 1, 2 plus minus 33.
Hey Yoga,
Yeah.
for 2C, right? Question 2C, right? I struggle. Can you teach me?
Oh yeah, sure, of course. Okay, so question number C, the question is find the polar equation of the conic. So basically, we use this equation here, we write that plus 2x plus 4y equals to 0. This is the equation. And as we know for polar equation, we learn x equals to r cos theta and y is equals to r sine theta. Right? So right now we need to substitute the x and y into this formula here. So let's substitute it. To 0. So now after we got this, the substitution, we need to expand it. When we expand it, it become like this, r square cos theta minus r square sine square theta plus 2r cos theta plus 4r sine theta equals to 0. So once we got it like this, you can see the similarity, right? The r is square. There are two, everything here have a r term. So we will like make it into, we take out the r out. Okay. So we left here like this, minus r sine square theta plus 2 cos theta plus 4 sine theta equals to 0. We got it into like this, and then here you can see that r is equals to 0, right? So when we know r is equals to 0, the remaining one we can just write back here, which is this minus r sine square theta plus 2 cos theta plus 4 sine theta equals to 0. And then after we got it into like this, we bring the one with the like nothing to do with r, which is this two term, to the other side, to the right side. So
here, these two terms are similar, right? So we take out the r out, cos 2 theta minus sine 2 theta equals to write like this. And then we just divide it so to the right side. So r is equals to negative 2 cos theta plus 4 sine theta over with cos square theta minus sine 2 theta. So when you can see here, this term below here, denominator, is known as a trigonometric identity. So we can change this as cos 2 theta to simplify. So we can summarize it as 2 cos theta plus 4 sine theta equals to cos 2 theta. So basically, this is the log space. I'll leave it to this way as the final answer.
No, can you teach me about the question 2D? I really don't know that the equation of the asymptote, the general one is what. Can you teach me?
Question D, okay, let me show you. For the question D is determine the equation of the asymptote of the conic and show that the asymptotes are perpendicular to each other. So first thing first, here is the equation for the hyperbola, and the formula of asymptote is y minus k equal to plus minus a over b times x minus h. So we will just put it on the number into the equation. So a is set 3 and b is set 3. So we can cancel out this and it will become 1. So we will solve the equation, and we will get here, which is the asymptote. First is y equal to x plus 3 and y equal negative x plus 1.
Bella, I have a doubt. I already get the answer for asymptote, but how about to show the asymptote are perpendicular to each other?
Oh, it's just a simple way. Let me show. So the question D wants us to determine the equation of the asymptotes of the conic and show that the asymptotes are perpendicular to each other. So we're going to answer this. Show that the asymptotes are perpendicular to each other. So after we get the asymptote equations, it's going to be easy. So to show that the asymptotes are perpendicular to each other, we will use the general slope equation, which is y equals to mx plus c. So we're going to use m, which is the gradients. So for the first equation, which is y equals to x plus 3, we get m1 equals to 1, while y equals to negative x plus 1, we will get m2 equals to negative 1. So to show that the lines are perpendicular to each other, the answer for m1 times multiple m2, it must equal to negative 1. So as you can see here, m1 times m2, which is negative 1, we will get negative 1 as the answer. So the conclusion is, since the product of slope is negative 1, then the two lines are perpendicular to each other. That means we successfully proved that it's perpendicular to each other.